Have you ever seen a glowing orb of light dancing through the air during a thunderstorm? A mysterious floating fireball that seems to defy the laws of physics? This isn't science fiction. It's a phenomenon known as ball lightning, and for centuries, it has baffled scientists and eyewitnesses alike. Reports describe these luminous spheres, ranging from the size of a golf ball to a beach ball, hovering, zipping around, and sometimes even passing through solid objects like walls and windows before vanishing, often with a pop or a bang. For a long time, these accounts were dismissed as hallucinations or optical illusions. But with thousands of documented sightings throughout history, the question remained, is ball lightning real? And if so, what on earth is it? Well, today, we're diving deep into one of nature's most bizarre and captivating mysteries. We'll explore the historical accounts, the scientific skepticism, and the groundbreaking theories that are finally shedding light on these ghostly fireballs. The answer, it turns out, might be even stranger than the mystery itself. So let's travel back in time. One of the earliest and most dramatic accounts comes from 1753. A pioneering scientist named Georg Wilhelm Richmann was in his lab in St. Petersburg, Russia, attempting to replicate Benjamin Franklin's famous kite experiment. He had set up a device to channel atmospheric electricity, but the experiment went horribly wrong. According to a witness, a pale blue ball of fire, about the size of a fist, shot out from the apparatus and struck Richmann in the head, killing him instantly. This tragic event became one of the first well-documented cases of ball lightning, lending terrifying credibility to what many had considered mere folklore. Throughout the 18th and 19th centuries, similar stories popped up. Sailors reported glowing balls dancing around the masts of their ships during storms. People saw them drift through their homes, seemingly unfazed by physical barriers. Even the Russian Tsar Nicholas II claimed to have witnessed the phenomenon as a child, describing how a fiery ball entered his room during a service and flew around before exiting. Despite these incredible stories, the scientific community remained largely unconvinced. The events were so rare and unpredictable that studying them was nearly impossible. How could a ball of light just float in midair? What could possibly power it? It seemed to break the known rules of nature. The tide began to turn in the 20th century. With the advent of cameras and more systematic data collection, the evidence became harder to ignore. In 2012, a team of scientists in China got incredibly lucky. While studying regular lightning on the Tibetan plateau, their high-speed cameras and spectrometers accidentally captured ball lightning in the wild. A lightning bolt struck the ground, and from the impact point, a glowing orb about 16 feet wide emerged and floated for nearly 2 seconds before disappearing. This was the smoking gun. For the first time, we had scientific data. The spectrometer, which analyzes the composition of light, revealed something fascinating. The light from the ball contained spectral lines of silicon, iron, and calcium, the very elements that made up the soil where the lightning struck. This observation gave a massive boost to one of the leading theories about ball lightning, the vaporized silicon hypothesis. Proposed by John Abrahamson in 2000, the theory suggests that when lightning strikes soil rich in silica and carbon, the intense heat vaporizes the silicon. This silicon vapor then cools and condenses into a floating aerosol of nano-sized silicon particles. As these particles react with oxygen in the air, they burn slowly, releasing energy in the form of light and heat. It's like a tiny floating firework made of dirt. This theory neatly explains several key features of ball lightning. It explains why it appears after a ground strike. It explains the presence of silicon in the Chinese observation. The slow oxidation of silicon nanoparticles could account for the ball's relatively long lifespan, lasting for seconds or even minutes. It also helps explain its movement. As a light, floating cloud of aerosol, it would be easily pushed around by air currents, making it appear to drift and hover. And what about passing through walls? Well, this is still a bit of a stretch, but some researchers suggest it might not pass through solid objects, but rather reform on the other side. A ball of plasma could potentially induce a current on the other side of a window pane, for example, creating a new ball. Or perhaps the eyewitness accounts were slightly mistaken, and the ball simply passed through an open window or a chimney. The vaporized silicon theory isn't the only game in town, though. Other scientists have proposed different explanations. One popular idea involves microwaves. Some physicists suggest that atmospheric microwave radiation, trapped inside a bubble of plasma, could create a glowing sphere. Another theory points to the annihilation of antimatter falling from space, though this is considered highly speculative. There's also the idea of masers, which are like lasers, but with microwaves, creating a localized pocket of superheated, glowing air. Scientists have even managed to create things that look a lot like ball lightning in the lab. Researchers in Brazil used silicon wafers and an electric arc to create small, fiery orbs that bounced around for several seconds before fizzling out. Other experiments have used microwave ovens, and please, do not try this at home, to create balls of plasma inside the oven by trapping microwaves. While these lab-created fireballs mimic some of the behaviors of natural ball lightning, none of them have perfectly replicated the full range of reported characteristics, like passing through solid objects or their sometimes long lifespans. Each successful experiment, however, adds another piece to the puzzle. What's becoming clear is that ball lightning might not be a single uniform phenomenon. It could be a catch-all term for several different things that all happen to look like a glowing ball of light. Some instances might be vaporized silicon, others might be electrical plasma phenomena, and some might even be something else entirely that we haven't even thought of yet. This diversity could explain the wide variation in eyewitness reports, different sizes, colors, durations, and behaviors. So where does that leave us? The mystery of ball lightning is not entirely solved, but we've made incredible progress. We've moved from dismissing it as a myth to capturing it on camera, analyzing its composition, and recreating similar effects in the lab. The vaporized silicon theory stands as the strongest contender, backed by that crucial 2012 observation, but the door remains open to other possibilities. What's truly exciting is that this is active, ongoing science. Every new thunderstorm, every new lab experiment could bring us one step closer to a complete understanding. The story of ball lightning is a perfect example of how science works. It starts with strange, seemingly impossible observations, moves through a period of skepticism and debate, and finally, through persistence and a little bit of luck, begins to form a coherent explanation. It reminds us that even in our modern world, there are still genuine mysteries hiding in plain sight, waiting to be unraveled. The floating fireballs that have mesmerized and terrified people for centuries are slowly giving up their secrets. The next time you're watching a thunderstorm, keep an eye out. You might just witness one of nature's most elusive and spectacular light shows. Thanks for watching, and if you enjoyed this journey into the heart of the storm, don't forget to like, subscribe, and hit that notification bell for more deep dives into the wonders of our world.